Hello guys, welcome back to Coding. So guys, I hope you all are doing great and having a lovely time, enjoying the videos that I'm posting for you and understanding each and every concept concise, clear and to the point. So in the previous video what we had discussed about what do you mean by semaphore, what do you mean by deadlock, and also explain your structure of deadlock modeling. So in today's lesson, whole of the focus will be on deadlock, like what is deadlock prevention, avoidance, what do you mean by deadlock recovery, and everything that will involves in a deadlock stage. All we are going to discuss in the video. So guys, if you're new to my channel, please do like it, share, and subscribe to my channel. Already on my YouTube channel, I posted content regarding C, C++, Java, Python, SQL, networking, operating system, Excel videos, Python top code, interview questions in short videos, everything that is really useful for a learner, for whoever wants to learn whichever field, all is available on my channel. That is also for free of cost. So please do give it a like and also subscribe to my channel. So let's get started with the video without wasting any time and understand what is deadlock. So as I previously told in the deadlock, basically deadlock is a situation in which two computer programs sharing the same resource are effectively preventing each other from accessing the resource. So this resulting in both programs seizing the function. So that is basically called as a deadlock. So we have basically deadlock modeling, which requires request, use and release. Request and release are called as the system calls. Now we are going to talk about the very first thing, like how we can prevent deadlock. So basically that is deadlock prevention. Now coming to what do we mean by deadlock prevention. At least one of the necessary conditions does not hold true. However, most prevention algorithms have poor resource utilization and hence release in reduced throughput. So basically what we can do, number one, eliminate mutual exclusion. It is not always possible to prevent deadlock by preventing mutual exclusion as certain resources cannot be shared safely. So now what is the very first thing? We need to eliminate mutual exclusion. Like we need to, and it is not possible always to prevent deadlock. So just in that case, we need to use mutual exclusion. Number two, eliminate hold and wait. The two approaches are used. Process can get all the required sources before it start execution. This will avoid deadlock, but will result in reduced throughputs as resources are held by the process even when they are not needed. Now some of the processes are something like even if we are not needing them, then also they are holding it. Number two situation in this only we can have to request for a resource when it is not holding any other resource. This may result in the starvation of as all other resources required may not be available free always. Now what will be this condition will do? Like it will just lead to starvation as because the all resources will not be free at the similar moment. So that is the other thing that we can eliminate hold and wait. Third, eliminate non-primitive. So if a process requests for a resource which is held by another waiting process, then the resource may be primitive from other waiting processes. So what we need to do, we need to eliminate non-primitive. Next, eliminate circular wait. Each resource will be assigned with numerical number. A process can request for a resource only in increasing order of number. If P resource is allocated R5 resource, next time if P1 asks for R4, R3, then such request will not be granted. Only request for the resource more than R5 will be granted. So what we can do, we can also eliminate the circular wait queue. So from these elimination, you can also understand like what do we mean by mutual exclusion, what do we mean by hold and wait and non-primitive and circular wait. So this is the way through which we can do deadlock prevention. The next thing that we have is the how we can do deadlock avoidance. So basically for deadlock avoidance, we have resource allocation graph algorithm and second is the banker's algorithm. Now for that, what we need to do, first of all, we need there are two states. One is a safe state and one is an unsafe state. Safe state. It is a state in which there is at least one order in which all the processes can be run to completion without resulting in a deadlock. A safe state is not a deadlock state. A deadlock state may lead to unsafe state. So basically a safe state is not a deadlock state. Second, we have the unsafe state. Unsafe state may or may not be in deadlock condition. It is deadlock, then it is unsafe state. If there is a cycle in the group, the chance of deadlock increases maximum. So these are the two states which are required to be understood. Like safe state is not a deadlock state, but if it is in an unsafe state, so it is a deadlock state. Talked about like we have two types of algorithms that we can use to avoid this deadlock. So basically first one is the resource algorithm. So basically it consists of vertices and edges. All the active processes are dominated by P. like P1, P2, P3, P4 and so on. Resources are donated by R1, R2, R3. So whenever a process needs a resource, it is donated, be noted by PI, RJ, and the edge is known as request edge. So whenever a resource is allocated, a process is donated by PI and then the arrow RJ and edge is known as assignment edge. Each process is represented by circle and resource by square. Dots with square represent the number of instances. If no cycle exists, the allocation of resources will leave the system in a safe state. This is just to tell you like what do we mean by resource allocation graph algorithm. If you want to discuss more about understand like how do we work with the resource allocation graph algorithm, do let me know in the comment section. I'll make a separate video for it. Second we have is the banker algorithm. So it is the best known as deadlock avoidance algorithm. It is suitable to the resource allocation system with multiple instances of each resource type. So basically it will have a allocation, maximum and the available. So it will consist of some processes and then it will provide a solution. As you can see on the screen, I have provided a table and also a solution of it, like how much is needed and how much is available for the resources to work in that desired process. When I'm talking about deadlock recovery, what do you mean by deadlock recovery? Number one, killing the processes. Like whenever you're using a system or we are using a mobile phone, there's an option task manager where you can kill the processes. So basically, killing all the processes involved in deadlock, kill processes one by one. After killing each process, check for deadlock again and keep repeating the process kill. System recovers from the deadlock. Like we have to keep on killing the processes unless the deadlock has been recovered. Second, resource preemption. Resources are preempted from the process involved in deadlock. Preemptive resources are allocated to another process, so that is the possibility of recovering the system from deadlock. So these are the ways through which we can help in what we can do deadlock recovery. So this is the whole scenario when we're talking about deadlock. I hope you must be about each and everything that what I explained about deadlock, deadlock prevention, deadlock handling, avoidance, and what are different types of algorithm that we are required in. So if you want a separate video for the algorithm, do let me know in the comment section. I'll create a separate video for that. So guys, I hope you must be about each and everything. Thank you so much for watching. Keep smiling and have a lovely day. And let me know in the comment how did you like the video. Do give it a like and also subscribe to my channel. Till then, bye bye. Take care.